Oh,
Well, also,
I think
if you miss first period and then you're not signed in there, then they're gonna ask you
they are not going to.
They will ask.
They
I
will
my son
ask.
a couple times just because.
All right. I've heard a few answers for this one.
It's either D or E.
It's
Either
C.
D or E or C.
Or A or B.
or A.
It's not A and it's not B.
So what strategies did we use here?
A is a circle.
It was on the homework. That's
Yeah,
why.
A is on the homework. It's a circle.
Okay. So what other strategies did we use here?
Yes.
Yeah.
Not the best strategy. No, it's not a good
It's a
strategy.
strategy.
It is a strategy, but not a good strategy.
And I'm pretty sure B would just end up with a circle again. Or a bigger circle.
I said it was C.
So if we look at our slopes, everything to the right of the y-axis has a positive slope. Everything to the left of the y-axis has a negative slope. That kind of tells us that the only thing that's going to affect the slope is the sign of the x-coordinate. Right? The sign of the y-coordinate doesn't really affect the slope. So in terms of our answer choices, that pretty much tells me that y is going to have to be squared. Okay? If the sign of y doesn't matter, then y will have to be squared. So, if everything where x is positive has a positive slope, and everything where x is negative has a negative slope, it would have to be an odd pattern. Right? So, I think E would be our answer.
See, I got it down to 2.
Does that logic make some sense? Alright. So how did the homework go?
It was fun.
You think it was fine? Let me...
Like, why didn't we do this at the beginning?
Because we didn't know how derivatives and
Yeah, you didn't know any of
stuff.
this stuff. So here are the answers for the matching multiple choice.
C, D, A, B, C, A, R, B. What is 16D?
Hey, I told you.
I thought it was A. I was pretty flipping confident it was A.
And I was confident it was D.
Then you should have went with your gut.
Yeah, I mean, that pattern, definitely looks like a cubic function. Right?
That's
Okay, you could have.
Any of these
Argue
that
with me.
we want to take a closer look at? No, we did not do 17. Questions on
Can
any of
you
these?
do 16?
Sure. Everybody
It's really
done with the answers? Alright. So,
It's tiny.
15 and 16 asked, here's a slope field, what could be a solution? Meaning, what could this be a picture of? Right? So if we're not talking about the derivative, we're not given dy dx, we're saying, what would y equal here? So on both of these, we kind of have to understand what the parent functions would look like. So if x squared, right, this doesn't really follow any x squared pattern, e to the x would be an exponential that would look like this. It doesn't really follow that pattern. E to the negative x would follow that curve. Right? It doesn't really follow that pattern. Cosine, right, just repeats itself. So I think our only option is natural log. The natural log function does follow that shape. Right, so I think our answer for this one would have to be E. Okay, and again, we should be able to recognize what shapes of these curves look like. Similar idea for 16 here. If we just kind of sketch in following our slopes here. It looks like we have something that looks like that. It looks like a cubic function to me. It's not sine or cosine. It's not a quadratic. This one would have to be cubic. So this one's E.
So if the dy dx isn't on there, then we don't do like the and, we don't look for the graph and. If the dy dx is on there, do the graph and. She's saying like if it were dy dx equals x squared, we could probably something with what's up there because it would be like
Oh, yes. Yes. Yeah, so if all of these said dy dx instead of y, this would be the right answer. Yeah. So yeah, make sure that you're paying attention to whether it's saying is this a graph of the solution, right? So we're given y's or we're given dy dx's. Anything else on the homework? Alright, then today we are going to
Not do math.
look at solving these differential equations.
oh my god. All I heard was thank you.
Yeah.
Oh, I thought he
You're
heard it
welcome.
because then he was like, yeah, and I thought he was talking. Sorry.
Nope.
I felt so weird because I thought he thought I was getting
Can't eat this.
You can suck on it.
I can suck on it, but I won't.
Take it
Oh,
anyway.
my brother.
Ah, you don't want a lifesaver. I'm trying to save your life, man.
It's already out. The armor is really strong. Oh,
I blame Chris.
What?
I blame Chris. Chris started my addiction.
Oh, he had the candied ones, not the mint ones.
Oh no, but I like the little ones. Got me on lifesavers.
Alright, so we started talking about how to solve differential equations yesterday. We have to separate the x's and the y's onto separate sides of the equation. So get all the x's and dx's on one side, all the y's and dy's on the other side. Now, when we do that, we have to be multiplying all of the x's times dx. We have to be multiplying all of the y's times dy. So, for example, if we were given something like this, that is not a separable differential equation. Because to get the x's on one side and the y's on the other, I would have to subtract y over here, right? And then I would multiply dx over here. When I subtract y over, I'm not multiplying y times dy. Okay, so for our purposes, this would not be a solvable equation. And whenever we're doing this, we have to make sure that we are multiplying all of the x's times dx and all of the y's times dy. All right, so what we're going to look at today is a lot of examples where we are given a dy dx and asked to find a general solution, meaning we'll have a plus c in there, and then we will be given an initial condition. Then we'll need to solve for c and give a specific solution. Okay, so let's start with an easy one here. Dy dx equals 4x. So how would I separate my variables here? Multiply the dx over, just get dy equals 4x dx. Then what? Take the antiderivative of both sides. Y equals 2x squared
Plus C.
plus c. Okay, so this would be the general solution to this differential equation. But then we want to find the specific solution that contains the point -3, 7. So I just want to solve for c now. So I'm going to plug -3 in for x, 7 in for y, and solve for c. So my actual answer here, the specific solution, would be y equals 2x squared minus 11. You okay with that one? That one's pretty straightforward, right? Never know y's that we had to bring over to the left side. So let's take a look at our second example here where we do have a y that we have to worry about now. So I've got dy dx equals negative x over y. Yeah, we've got a fraction equal to a fraction. That's essentially what we'll do here. So we can say y dy equals negative x dx. Separate the variables. And take the antiderivative of both sides. 1/2 y squared equals negative 1/2 x squared plus c. So now we want to differentiate on what the question is asking us. So here, we're just solving for a specific solution. Right? It might be easier, and in most cases it is, from this step to plug in your initial condition. Okay, so instead of solving for y first, and then plugging in your initial condition to solve for c, it's probably going to be easier from this step to plug in your initial condition, solve for c. Okay, so what that looks like then, if I plug in the point 0, 2, I would have 1/2 2 squared equals negative 1/2 times 0 squared plus c. So we just end up with c equals 2. So now, I'm going to plug 2 in for c, and to get my solution, I still do need to solve for y. Right? It's just usually easier to solve for c if we go from this step before we actually solve for y. So, to solve for y, multiply both sides by 2. So y squared equals negative x squared plus 4. Take the square root. Y equals. And they do give us this piece of information as well, that y is only positive. So what that means here is when I take the square root, I only need to include the positive root, not the negative root, so I don't need the plus or minus. So I'll just have the square root of negative x squared plus 4. Whenever we're adding or subtracting things inside of a radical, we cannot take those things separately. You okay with that one? Not too bad, right? Alright, how about this one? dy dx equals x times y.
We can multiply the x over, divide by y.
Alright, multiply the dx over, and then divide by y. So we would end up with dy over y equals x dx. Now I can take the antiderivative of both sides. What's the antiderivative of dy over y?
By -1, add 1, 0.
It's
Natural log.
Oh, okay.
Right? We've got du over u, or u prime over u. The antiderivative of that is natural log. So here we would get natural log of y. Okay, and remember, whenever a log is the antiderivative, we need the absolute value. So natural log of the absolute value of y equals 1/2 x squared plus c. Alright. So now, again, if I wanted to get my general solution, okay, I could solve for y from here, but if I'm looking for a specific solution, it's probably going to be easier to plug my coordinates in now. So if I plug 1, 1 in, natural log of 1 equals 1/2 times 1 squared plus c. What's the natural log of 1? 0. So we get 0 equals 1/2 plus c. So c is negative 1/2. So now, let's come back over here and plug that in. 1/2 x squared minus 1/2. Now, how would I solve this for y? The e. Yeah. So the inverse of a natural log function is raising that to a power of e. Right? So to undo natural log, both sides of the equation are going to be raised to a power of e. So e to the natural log just cancels out, and we'll end up with y equals e to the 1/2 x squared minus 1/2 power.
Happens to the absolute value.
That's a good question. In this case, yeah, it doesn't really matter.
But if we do get to the case where it does matter, what would you do?
Just keep the absolute value function.
Around what?
Alright. We okay with that one? Now, I actually do want to talk about just finding the general solution of this as well, because there's one thing that the AP test does that's a little funky. So if from here, including the plus c, I would use the same strategy. Right? I would raise both sides to a power of e. So we have e to the natural log of y equals e to the 1/2 x squared plus c. So y equals e to the 1/2 x squared plus c power. Now here, they tend to use an exponent rule and say that this would be the same as e to the 1/2 x squared times e to the c power. Okay? Remember, whenever you're adding exponents, you can split that up into two separate terms that are being multiplied, like this. And then they will say that this is still just a constant. Right? E to some number is still just some number. So they will say that this is the arbitrary constant and write the answer like this: c times e to the 1/2 x squared power. Yes, you will.
You have too much faith.
Right? A lot of if this were a multiple choice question, okay, a lot of times they would present the answer like this. You okay with that? Make a little bit of sense? Maybe now.
Yeah.
I mean, it makes
sense.
And then we try
Then
it.
what are those looks for?
We're not gonna be able to do this without.
Yes, yes, you will.
If we don't like the really define gravity, we play back with something, and we died. We physically died.
Or we just surpass the A test and go right to review. The AP test is more important than.
You're right, but I feel like the unit test really forces you to learn the information. Because you will study them. Alright, let's take a look at number 4 here.
Okay.
What did you say?
I don't like this.
The phrase he says you shouldn't start sentences in the left field, but fine.
Oh.
Tired. So it's basically
Alright, I feel like it does.
you need to start
Okay, let's do this math.
Alright, how would I split this one up? How would I separate the variables here? No.
He said, how do you split the page? Well, since they're multiplied, you can make it 2 different squares, right?
We could say this is the same as the square root of s times the square root of t. So now,
Multiply t over.
right, we can multiply the dt over, divide the square root of s over, and I'm going to go ahead and write this. So if I divide that, I would have the square root of s at the bottom, which would be the same as s to the negative 1/2 power, right? And then over here, this would be the same as t to the positive 1/2 power. So now, we take our antiderivative of both sides. What's the antiderivative of s to the negative 1/2?
That equals 2 t.
So now we can plug in our initial condition, t equals 0 and s equals 1. So 2 times 1 to the 1/2 equals 2/3 times 0 to the 3/2.
Well,
What? Are you talking about the left side of the equation?
Yeah.
So 1 to the 1/2 would be 1 times 2 would be 2. So we just end up with c equals 2, right? Then we can plug 2 in for c and solve for s. So 2s to the 1/2 equals 2/3 t to the 3/2 plus 2.
divide by 2.
Divided by 2.
What?
I know. Wait, I have a question.
Okay.
Why do we have to solve for s? Is it just because it's not like a point?
So yeah, this is just saying that an original point on the graph is this. So we're going to solve for the whole equation of the graph. Okay, so then how do I get rid of this 1/2 power?
Oh, yes, squared.
Right, we want to square both sides. And so if I square both sides, we'll just end up with 1/3 t to the 3/2 plus 1 squared. Did you just say, so this is calculus? Oh, okay. As opposed to just calculus that we were doing before. It is. I mean, yes. This is.
I just lived in this unit. That was such a mega thing to say.
Yes, you can.
I declared it to them.
I want Mr. Clark to come in on his podcast time.
All right. What questions do we have here?
I think this just kind of needs practice.
You just heard